Hi guys, my name is Scott from Chegg Tutors, and I typically tutor subjects such as statistics, psychology, sociology, physics, chemistry, and biology. And today we're actually going to be going over a statistics concept. More specifically, we're going to be going over permutations and combinations. Now, permutations and combinations are more or less seen in upper division math, but they're also kind of seen in upper level statistics, more specifically in probability, okay? So let's go ahead and jump right into it. You'll see that I've already drawn a little bit of here up on the board. So let's go ahead and first understand the difference between permutations and combinations. Now, at least for permutations, both of them sound rather very difficult to understand, but it's really important when to use combination and when to use a permutation, okay? When it comes to a permutation, permutation is a scenario in which order matters, okay? And what does it mean by order mattering? Order mattering is we have an example, for instance, we have 5 people and we want to award these people first, second, and third place trophies. And we only have 3 of these trophies, and order matters in this case because we only have 1 first place trophy, 1 second place trophy, and 1 third place trophy. Okay, so this is an example of which order matters. But something for like a combination is an instance in which order doesn't matter. And this is an instance for, say, we have 5 people again, but instead of giving trophies first, second, and third, we're actually just giving, I don't know, like distinction ribbons or something like that. Something where order doesn't matter, that you could give a distinction ribbon to, you know, one person, another person, and another person, and that's not going to change anything, right? Okay, so about this example I have up on the board, say we have at least 5 people here, A, B, C, D, and E, and we decide to give, we have at least 5 different options to give the first place trophy to, and in this case I'm going to give it to person A, okay? So then for our second place trophy, we only have 4 options to give our second place trophy to. So I gave it to B in this case. And then for the last option, I only have 3 options to choose for my third place trophy, okay? So that means that these are the different options that I'm going to end up having. 5 times 4 times 3, right? And this is going to give me the total amount of different options that I could give to all of my people, right? To all of my contestants. So 5 times 4 times 3 to get us, what is it? That's going to be 20. So 60 different options that we could end up getting, okay? So we've actually kind of seen, for those of you who've taken like upper division mathematics, you've actually kind of seen something similar to what we have right here. And this is actually going to play a role in 5 factorial, okay, or the symbol factorial. For those of you who haven't seen a factorial, is when we have an exclamation point written by one of our numbers, okay? So 5 factorial is actually going to end up equaling 5 times 4 times 3 times 2 times 1. And in this instance, we're not interested in the 2 times 1, okay? We're just interested in this part. So let me go ahead and go to the next board here. And you'll see that I've already started to work on the problem a little bit, and you'll see here that we are using the permutation formula here, right? So n is going to be the number of people that we have, and that's going to be 5, okay? And then in terms of k, k is the type of order that we want to have. All right, so we have 3 trophies to give, so we're going to be using 3 for k. All right, so we're going to do 5 factorial divided by 5 minus 3 factorial, and that's going to give us 5 factorial over 2 factorial. So in this case, we're going to get that whole 5 times 4 times 3 times 2 times 1, but then we're actually going to also be dividing by 2 factorial, okay? So that's going to give us 2 times 1. And that's going to end up actually canceling out what we have in our numerator. And again, this is going to give us the amount of options that we could have. We could do ABC, CBA, ABD, ACE, anything along those lines. And that's going to give us, and if we do all those together, that's going to end up giving us 60. Okay? Now, let's go ahead and talk about combinations. Now, combinations are different from permutations because, at least when it comes to combinations are really easygoing, and order really doesn't matter here. So you could do, say for, like I said in our previous example, instead of giving trophies, we're just giving away distinction merits or distinction awards. So you could give a distinction award to A, a distinction award to B, and a distinction award to C, and and that's it. You know, you don't have to worry about which of those people came first. If you get so for instance, say for example, I did this whole A, B, C thing again. A, B, C, D, E. If I gave away my distinction merit to A, and then B, C, D, E, just go ahead and go down to C, D, E, because I already know I'm gonna give my distinction merit to B here. I'm gonna do distinction merit to B, and then a distinction merit to C. Okay, so again, this is very similar. So you would, at first you would think like, oh, okay, well, it's kind of like similar to permutations. I have 5 times 4 times 3, and I get them different combinations that I'm going to end up getting. But you can't do this in this case, because if you did the 5 times 4 times 3, then this is including all the repeats that we would end up getting. So if we did A, B, C, and then we gave distinction merits to C, B, A, if we did 5 times 4 times 3, that's including that, okay? Because that's when order is mattering, right? If we did A, B, C, and C, B, A. But in Leastman's combinations, order doesn't matter. So we want to get rid of all those repeats, okay? So at least when it comes to the combination formula, for a combination formula, it's going to be C, N, K. In here, we're going to do n factorial, n minus k, which is very similar to our permutation formula. But then we're also going to multiply it by k factorial. Okay? All right, so in this case, for our previous problem, when it comes to the distinction merits or distinction ribbons, we would have 5 factorial. Again, we're going to be using 3 here for our k. So that means that we're going to do 5 minus 3 factorial, and also 3 factorial. And that's going to, like I said, give us something drastically different, okay? So that's going to end up giving us 5 factorial divided by 2 factorial times 3 factorial, okay? Again, something drastically different. So, but what this combination formula ends up doing is that it ends up taking out all those different repeats that we ended up having in our previous formula, right? In our previous permutation formula. So instead of having repeats like A, B, C, and C, B, A, it would take one of those out. It would account for one of those things. And in this case, order isn't going to end up mattering when it comes to combinations, okay? And it's going to eventually give you the options or the amount of combinations that you could use where order doesn't matter. So let's just do that real quick. Remember from our previous example, we would take out 2 factorial from the numerator. We would take out 2 factorial from the numerator. So we have 5 times 4 times 3 divided by 3 times 2 times 1. Because that's what we have in our numerator because of 3 factorial. We can cancel out these 3's. We can cancel out a 2 and replace this with a 2 up here, and anything divided by 1 is itself. And we end up getting 10. So 10 would be the amount of different combinations that we could use in which order doesn't matter, okay? So if we did A, B, C, and then C, B, A, those are essentially the same thing, okay? And these are the amount of combinations that we could use in which, like I said, order doesn't end up mattering, okay? Now, you might end up seeing combinations and permutations when it comes to upper level division statistics, or when it comes to upper division math as well, especially when it comes to probability. If you have any questions for me in regards to this video tutorial or combinations and permutations in general, or other questions in terms of chemistry, biology, statistics, psychology, sociology, physics, anything along those lines, then feel free to send me a message at my personal Chegg page. You can see I have it linked there up on the board. Other than that, I hope you guys have a great day.